In this video, we're going to talk about functions. This is in connection to the previously discussed topic. So we're just going to go ahead and dive in. So the two objectives that we're going to do today is come up with a mathematical model for real life problems and perform operations on functions. So what is a mathematical model anyway? A mathematical model or mathematical models are functions that describe the dependence of one quantity to another. So let's go ahead and have a real life example so that you would see and understand what it means. Jamie is planning for a simple surprise birthday party for her close friend Mandy. Jamie thought of availing the amenities of a nearby hotel. A private room, which can accommodate 40 people, will cost her 2,000 pesos for 3 hours, inclusive of use of sound system and karaoke. Availing of their catering service will cost 250 pesos per person, inclusive of drinks, with a minimum of 20 guests. Now, the question is, how much will Jamie pay if she plans to use the private room for 3 hours and invite 20 guests? How about 25 guests or 30 guests? So the first thing that we need to do is to first assign specific letters for the unknowns or the given here. So here we have T for the total payment that she's going to pay. R is the fee for the room, which is for the 3 hours. F is the cost of food per person, which is the 250 there. N is the number of guests. So as you can see here, the total payment would actually be equal to what? That's the R, the fee for the room. Remember that the fee of the room is just for the 40 people already. Alright, so that's just 1R there plus the food times the number of guests. And I think that's fairly straightforward there. So you pay for the room and the for the whole event, and then for the food it's per person, and then the person is the number of people is represented by n in here. So what we're going to do is we're going to expand that. This is equal to 2,000. R is already 2,000 in here, as you can see. That's 2,000 pesos for the fee of the room, plus the F, which is the cost of food per person, which is 250 times the N. So the N here, I place it as N because I'm not gonna specify yet if it's 20, 25, or 30. What we're doing here is that we're trying to model a function. So when we say model a function, or modeling a problem with a function, we're actually looking for an equation that would somewhat resemble a formula in finding a specific value. In this case, we're trying to look for the value of the total payment with the use of the number of guests. So a more appropriate way of writing it down is T of n, meaning the total payment is a function of the number of guests. When we say the total payment is a function of the number of guests, we mean that the value of T is dependent on n, which makes sense, right? Now this is equal to 2,000 plus 250 n, and that's a mathematical model then of this real life problem. Now, in order for us to answer that, let's go to have the questions there. So we have t sub 20. So if you could remember, when we have t sub 20, we just simply evaluate the function. So we have 2,000 plus 250 times 200, which is equal to 7,000. And then everything else should follow. Now you might ask, sir, why do we have to talk about mathematical models when we are business people, when we're gonna be doctors, and what other professions out there? So I might tell you this, that there are actually kinds of functions that are applicable in different areas or professions. It's just that we don't sometimes get to know them. That's why we don't appreciate. So I'm just gonna give you like some of the few examples of the use of functions in different professions. In medicine, this is a legit, like this is literally like a true function. This is a rational function, rational meaning fraction, which talks about the concentration, which is C, of a specific drug in the bloodstream of a patient. So like for example, if it's anesthesia, T, by the way, here talks about time in hours. So like for example, um, if anesthesia is injected in the bloodstream of the patient, this would actually help us understand the concentration, the change of the concentration of the drug in the bloodstream. So of course, if you were like operating on like a patient, you wouldn't operate at the first few hours of injecting the anesthesia. Of course, it's not gonna be properly concentrated. You would probably aim for the one at the top, so probably like 1 to 2 hours. Just like a guess in this case. But therefore, if you think about it, when we are doctors or professionals, we don't guess. We would need to use appropriate tools and appropriate ways of thinking for us to be very specific in the course of our action, so that we don't kill anyone accidentally. Now, in the case of finance, like for example, this one here is a function of the accumulated. A here is accumulated value, or your total amount, and T here is in years. So this is talking about, what if, take for example, you put 1,000 pesos in a bank account. I don't know if it's a possible. It's not possible in reality, but this is just for the sake of modeling. So let's just say we put that value 1,000 in an account, and we leave that for 4 years. So how is it gonna look like basically? So as you can see, there is a trend. So of course, if you don't withdraw any amount from that bank account, the amount was just gonna go ahead and double or triple, or increase exponentially. And one last example that I'm going to share to you. I don't know if someone's going to be an aerospace engineer, but in aerospace engineering, there is something that we call the decay of radioactive substance. Now, why do we need to talk about that? Because when certain missions or certain spaceships or satellites are sent outside of Earth, um, they run not through gasoline, because there's no gas station in space, right? So they use um, radioactive substance, particularly that's uranium 235. Um, the engineer should know how fast is the decay of the radioactive substance, so that they would know how much fuel left will be in the specific time frame that you would want the mission to run. So to show you the equation, it looks like this. It's gonna be fast. That was it. So I'm not gonna flash it. That was just to give you a jump scare. But basically, the math might be hard, but there are basics in all of these things. Like when we talk about engineering, architecture, business, or whatever, it talks about first. It is there is like fundamental concepts, and those are the things that we're gonna talk about here in general mathematics. So if I continue, let's talk about a more realistic or a practical example. So as mandated in Cebu City, there is a standard parking fees. So 20 pesos for the first 3 hours, and 5 pesos for every succeeding hours, or a fraction of that. By the way, 3 hours, it could be like a fraction of that, still 20 pesos. So meaning if you stay there for 2 hours and 45 minutes, that's still 20 pesos. And if your succeeding hour is like, for example, 3 hours and 30 minutes, that's still an additional 5 pesos, because that's the standard. It's not followed by all of the parking areas though, but it's the standard which the Cebu City government follows. Okay, so we will assign letters again. So F is for the total parking fee. T is the amount of time in hours you have parked in there. So F of t here, you might think, sir, the answer would be 20 plus 5t. Okay, so think about it. Is that correct? Answer is no, not correct. Because what if, for example, you stayed there at the first hour? So if you evaluate that here, that becomes 20 plus 5 and 1 here. If you evaluate that, so the answer will be 25. But that's the first hour only, because you're supposed only to pay 20 pesos on the first 3 hours. So this actually would not make sense. But you might think, sir, what if the answer is just only 20? But 20 only applies only when you are there for the first 3 hours. And the second one here only apply for the succeeding hours. So meaning like probably a fraction of the fourth hour. So 3 hours and 20 minutes, 3 hours and 45 minutes, or so on and so forth. So therefore, individually, they are not exactly, you know, appropriate for the function. But then again, there should be a way to put them together so that we could have the correct function then. So how do we do that? So we write it this way. Not this exactly way, but I'm just gonna try to help you understand it better. So we pay 20 pesos. So the function is that we pay 20 pesos whenever t is the first 3 hours. So when we say the first 3 hours, that should first start at the first hour, right? So we don't count -1 hour, -2 hours, or 0 hours. Of course, you won't pay anything if you haven't stayed there. So therefore, if you think about it, that for you to pay 20 pesos, time should be between 0 to 3. So 0 not included, 3 included, right? So if you have stayed there for a minute, that's 20 pesos already. And then if you stayed there exactly at 3, so that's 20 pesos also. But you pay 20 plus 5t, or 20 pesos plus 5t whenever t is the succeeding hours after 3 hours. So I mean 3 hours and 20 minutes and so on. But there is a more appropriate way of writing it down, and this is how you write it down. So the function t is equal to 20 whenever t is less than or equal to 3, but greater than 0. And 20 plus 5t when the t, or the time, is greater than 3. So what is this kind of function anyway? A while ago, the function that we had for Jamie was a linear function, which is really easy. But this one here is what we call a piecewise function. Now, what is a piecewise function anyway? A piecewise function is, these are functions which consists of two or more functions in specified subset of the domain. So there are specified subset of the domain, and there are different functions. So the functions that you saw a while ago are what we call subfunctions. So here, let's have another example. So these two here are subfunctions of f of x, meaning two parts of the function. So if you go ahead and try to make sense out of this one here, x minus 1 is a linear function. 2 minus x squared is a parabola. It's a quadratic function, meaning it's a parabola. Because it's negative, it's a parabola opening downward. This is a linear function, meaning the function is aligned, or the graph is aligned. Now, when is it aligned? It's aligned when x is greater than 2. So 2, 3, 4, 5, and so on to positive infinity, it's always a line. It would look like a line. The graph of the function would look like a line. Now, when we go below 2, or at 2 exactly, going down to negative 1, 0, -1, and so on, that will be a parabola opening downward. As you can see here, these are two different symbols. This one here means that 2 is not included. This one here means that 2 is included. So appropriate term for that is that this is a strict inequality, and this is a non-strict inequality. Strict because 2 is not included, non-strict because 2 is still included. So for you to understand, I'll show to you a graph. So this is how the graph looks like. As you can see here, there's a line and there's a parabola, right? So the line here only starts from 2, see? 2 going to positive infinity. And there's a hollow there because remember, it's not included. This one here is a parabola opening downward, which is that exactly thing there. And it's only parabola whenever x is less than or equal to 2. Exactly why we had to shade the dot here for 2, and then the parabola going opening downwards from 2 to negative infinity. And I hope that would, explain or help you visualize what a piecewise function is. So therefore, we're done with the first objective, which is to come up with a mathematical model for our real-life problems. So let's go to the operations on functions. So the operations on functions are really just the same as the 4 basic operations, but there's another added one. So addition, subtraction, multiplication, division, and the new one that we're going to talk about is composition. We're going to try to define that later on and show examples also. So let's just start by defining two functions. Two functions, f of x is equal to 2x plus 3, and another function, g of x is equal to 4x squared minus 9. In addition, what if, for example, we say, what is the sum of f of x plus g of x? So simply what we do is that we just really add the functions themselves, right? So if we have f plus g here, we're just really adding f, which is 2x plus 3, and g, 4x squared minus 9. And as you can see on this next step, I just regroup them so that I write them properly, that it's this the power is descending order, and I will have to combine like terms. In this case, I would have to combine positive 3 and negative 9, and that should give me a negative 6, and that should be the answer. Now what if, take for example, you'll be asked what is the sum of g of x and f of x. So you add g plus f. So you don't need to add that anymore, because we should know already about the commutative property of addition, which means which says that if you switch the order or change the order of numbers in addition, the answer would be correct. It would be still the same. So if we say 2 plus 3, that's 5. 3 plus 2 is still 5. So commutative, meaning even if you commute or you change the position of one number to another position, the answer would still be the same. So let's go to subtraction. So really straightforward. What we're going to do is just subtract the two functions here. And as you can see, remember that if this is a negative and there's a parentheses here, you need to distribute that negative to all of the terms inside the parentheses. So that becomes negative 4x and positive 9. So as you can see, that's what happened here. Negative 4x, positive 9. Still the same here because there's no negative outside. And let's go ahead and add like terms, and you should reach to the answer of negative 4x squared plus 2x plus 12. Now what if the question is, so what is g of x minus f of x? It's just that, is it the same as f minus g? Answer is no, because subtraction is non-commutative. You cannot, if you think about it, 3 minus 2 is 1, but 2 minus 3 is negative 1, so it's really different. So they're not commutative. So let's go to multiplication. So same thing. So we go ahead and multiply, and we do FOIL method here. And by doing FOIL method, you should reach this answer. 8x cubed plus 12x squared minus 18x minus 27. This is just really doing FOIL, expanding it. Same question. What if we multiply g to f instead, not f to g? Remember, 2 times 3 is 6. 3 times 2 is also 6. So meaning there is such a thing as commutative property of multiplication. So it's the same thing. So if you multiply f times g, it's the same as g times f. Let's go to the next one, division. So when we divide, it's the same thing. So the first number here, the first function that we see here is what we call the divisor. So the f here is the dividend, and this is the divisor. So here, the dividend divisor. And when you can't divide, please don't think that you're gonna do like long division or whatever kind of stuff. If you can't divide, just go ahead and express it as a fraction. And if you can't cancel out anything common, so you just leave it as it is. By the way, there's no need for you to put parentheses here, but I just place it there for you to see. But it's the same thing. So next question, what if you divide g by f? I think you know the answer. When you divide it, it's not the same as dividing f by g, because when you divide 2 by 1, when you have 2 divided by 1, that's 2. But when you have 1 divided by 2, that's 1/2. So really not the same. So non-communicative still. Commutative, non-communicative. Same for subtraction. Go to the last one here, which is composition of functions. Now this is read as f of g. So this is of. So f of g. So what's going to happen is that if we have f of g, so when we say composition of function, we're actually saying to evaluate the first function using the second function. So if you could remember when we evaluate, so I have an example here below. So if you evaluate f by 2, what's going to happen is that looking at this function here, what's going to happen is it becomes 2 times 2 plus 3, meaning the 2 here, which was supposedly x, becomes the 2 here also in the x inside the function. So that's what's going to happen here. So instead of putting a 2, we're going to put the whole function in itself within f of x. So just for you to see, it would look like this. So it actually is a function within a function. So you're putting a function inside a function. So instead of putting a 2 or any number here, it's the whole 4x squared minus 9 inside the x there. So as you can see, that becomes 2 times 4x squared minus 9 plus 3. And if you go ahead and expand that, it should give you this answer. So 2 times 4x squared is 8x squared. 2 times negative 9 is negative 18 plus 3. And go ahead and add what's similar terms there, and you should have 8x squared minus 15. Now, if you might ask, sir, what if, for example, we're going to look for g of f of x? Is that commutative? If you think about it for a while, the answer is no. It's non-commutative also. So you can't. So if you try to switch them, the answer would not be 8x squared minus 15 anymore. It will be a different answer. So we have already done the two parts here. So come up with a mathematical model for real life problems, and we've done piecewise functions and perform operations on functions, and we've done addition, subtraction, multiplication, division, and composition.